This is lesson 3, video 1 for unit 9, weak acids and weak bases. So in this lesson, we're going to focus on polyprotic acids. Polyprotic acid is an acid that donates more than one H plus during ionization. Now, this ionization is stepwise. So what that means is it's one H plus at a time. So we're going to use one very common polyprotic acid, phosphoric acid, H3PO4, as our example of what is going to go on as each H plus is going to be ionized. So if we have, and we start here with H3PO4, phosphoric acid, if we mix that with water, we get H2PO4 minus plus H3O plus. Well, we still have H2PO4 minus here, so this can act as an acid when mixed with water, and it can further ionize. So we get HPO4 minus 2 plus H3O plus. Well, we still have an H attached to the HPO4 minus 2, so it can act like an acid with water, and we can finally get PO4 minus 3 plus H3O plus. So all three of these H3O pluses contribute to the pH. There is a chart in your purple reference sheet for polyprotic acids, and it gives you the Ka values. So if we look at the Ka values for these three equations, we'll see that the first one is 7.5 times 10 to the minus third. That's pretty big. So that means that this is ionizing a good bit. But when we get to the Ka of the second step, 6.2 times 10 to the minus 8, that's such a small number. Hardly any of this breaks down, but it does break down. And then our last Ka is 4.8 times 10 to the minus 13th, which is so small that it's virtually no H3O plus is added in. So if we compare these values and they get very small quickly, we can conclude that most of the ionization takes place in the first step. That's not always the case, but for phosphoric acid, if these numbers are progressively smaller, then that means that this one is going to contribute the most to the pH. These may not even be significant enough. Now, of all of the diprotic and polyprotic acids, sulfuric acid is the exception. It is special. We have to treat it differently than any other polyprotic acid. And the reason why is the first ionization is about 100%. So it's labeled a strong acid. But the second ionization, which is HSO4 minus, is small, which means that it is a weak acid. So this one kind of is a 1-2 punch. So almost all of H2SO4 breaks down into HSO4 plus H3O, but then a little bit of HSO4 breaks down to give us a little bit more H3O plus. So it's included in the strong acids, but we don't multiply it by 2. We did that last time, but this time It's going to be a little bit different. So our next video is going to look at how we work with sulfuric acid.